what a fun place to have an IoT conference, huh? Orlando, the happiest place on earth. I'm actually getting used to whenever you pick up the phone, they say, and you ask for something, they say, have a magical day. That's like, I don't know how to respond to that, have a magical day, right? We're here to talk about IoT, and I am the Vice President of Strategy and Solutions at Intel in their IoT division. And I'll spend a bit of time talking about IoT, what we think about some of the strategies in IoT, solutions in IoT, and some time around what we think are the barriers to success in IoT. I try to represent quite extensively the industry point of view. There will be some Intel perspectives, of course, and very much how we see the world, but then as well as where we think our customers stand. So let's get started. So most people will tell you about IoT and it's solving the world's problems. And actually it is. There is quite extensive amount of data that says what we're trying to do in IoT is very much along the lines of real world problems and solving real world problems. I'll tell you a little story. My brother is a pediatric gastroenterologist. And so my parents are always like, wow, he's saving lives. What are you doing? You're an engineer. So actually, you know what? I'm actually saving some lives here. And we'll talk spend some time talking about that. But today, 5 million patients are remotely monitored across the globe. That's actually in 2015, so it's much higher than that, and it's increasing by 51% year on year. So what IoT enables us to do is to remotely monitor patients and give some independence to those patients, right? The World Health Organization says that 92% of our population lives does not have clean air. I spent Christmas in India and China, and it is unfortunate when that part of the world is living at, I think it's 5 times the World Health Organization's max of air pollution. And so one of the solutions that Intel's been working on is the Bosch Air Quality Monitoring Solution. It allows for this information and data. Data provides for insights. Insights provides for solutions. And so again, a lot of what we're trying to do is create the platforms and the environment such that we can do something about these problems. The impact on autonomous driving. So the ultimate driving machine no longer being the ultimate driving machine. So what is it going to be? I like the example of getting a car for free because the data coming out of that car is so extensively important that could that be a solution? It's yet to be seen. There are some very, very creative solutions. Could a car manufacturing buy a city? That's another option, right? So there's lots of different options there. But when we think about autonomous driving, also think about the fact that it enables independence for individuals that cannot drive. Our population is getting older. And so by 2030, there'll be 53.7 million people in the world that are in the US that are greater than 70. That's over a 50% increase. And so I'm looking around the room. No, joking. I was going to poke out some people, but I'm joking. But we're all getting older, trust me, I'm there with you. We're all getting older, and that allows for that independence for individuals. A great 16 million people today live without public transportation or access to public transportation. So yes, we are talking about autonomous driving, and there's really some real cool, neat, sexy entertainment opportunities with autonomous driving. But even more so, what does it do for air pollution? What does it do for the population and movement of population and independence of individuals? So you probably saw, if you've been around all day, you've seen a very similar point of view from our Wind River colleagues. Are they in the room? I think they are. I'm going to get him. There he is. because you told me you were going to sit through my presentation. So there you are. You got lucky. You're like, shoot, I just sat down. So you probably saw a very similar point of view from our Wind River colleagues in the room about how we see the world. And how we see IoT and the phases of IoT. He talked about connect the unconnected. That's phase one. Phase two is making those connections smart, and phase three being autonomous. So what do we see these phases to be? They're not really phases. You showed a really neat slide with it being platforms or horizons. They're actually very simultaneous. We see them happening in conjunction at our customers. So there's not, I'll give you the perfect example. I'm about to get on a plane as soon as I get off stage, and your plane, the flight you're taking, is the ultimate autonomy, example of autonomy. That thing can drive itself. Check in your luggage, and I'll tell you there is no monitoring on those things. And so in an industry like transportation or airplanes, you see that there's a mix. Some are very autonomous at parts of the industry, and then other parts of the same company or same industry will be very unconnected. And so our customers are feeling this dichotomy of parts of their business being autonomous, other parts not being connected, and how do we take this old data and combine it with this new data and make true decisions out of those. But as we move into autonomy, what you'll see is the dynamics that happens in that world of autonomy is real-time data, artificial intelligence, machine learning. And that's what's necessary to truly have an autonomous world. I'm going to spend some more time around autonomy and how we believe compute changes, connectivity changes, and just how the true total solution thing to cloud changes as a result of this autonomy. And when we get into this world of autonomy, this is where our friends at Wind River are very valuable for us, because what customers are truly looking for are solutions. They're looking for solutions that combine hardware, software, security. I've heard blockchain mentioned. I'm going to talk about that in a little bit as to how that fits into the world of autonomy, because all of this comes together as we move into that third phase. And I'm going to show a customer example in a bit that actually demonstrates it's happening today for us. So as we move into the world of autonomy, let's spend a little bit of time talking about artificial intelligence. There was $4 billion spent in artificial intelligence for startups just in 2016. There is a great deal of investment in this area. 2017, there's $5 to $6 billion spent. That's over $2 billion more than what was spent the year before, 2016. Amazon, Google, Facebook, and of course Intel are spending a great deal of money in this space. For Intel specifically, we bought Movidius, Nirvana, Itzy's, and Mobileye, all of which is in the space of artificial intelligence. That's over $1 billion of investments just with those acquisitions alone. And so as you look at this world, why this investment in artificial intelligence, that combines along with the investments that we're making and what we believe is happening with autonomy in the industry. And when we move to this world of autonomy where AI, artificial intelligence, and machine learning, and these capabilities allow us to truly make decisions at the edge. But when we start to do that and data starts to move to the edge, you now have lots of different use cases that are opened up to you. So one of the very typical use cases that my daughters have truly taken advantage of is standing in the middle of the kitchen and say, Alexa, order me marshmallows. And an hour, marshmallows show up. So for them, IoT is mama bringing marshmallows. But the world is much more advanced. And when we talk about AI, it's happening today and much more than what we see in the world of Alexa. Speech recognition is now, but in the next 2 to 10 years, we see applications taking off from predictive maintenance. I heard the example of agriculture. And it seems like an older industry, but there's quite a bit of innovation happening in the space of agriculture. So imagine taking the information of what you have on the soil along with weather patterns to determine how much water you need to use in your agriculture or in your farms. Imagine using videos to determine the health of your plants and doing video analytics to determine the health of your plants. And so and disease of plants and irrigation of plants. And so these industries are completely evolving as a result or reinventing as a result of the capabilities that we have now with artificial intelligence. And those capabilities of artificial intelligence starts to drive data to the edge. Starts to drive data to the edge. So I'm going to spend a bit of time talking about why, when you start driving data to the edge, now what happens to security? What happens to compute? But before we do that, I've got a video here with one of my customers. I get the luxury of spending time with a great deal of these guys that are doing a magnificent innovation. Hikvision's one of them. I actually went to their factory and saw what you're about to see with their little robots. It's amazing. And the point I'm trying to make, and what I want to emphasize with this video is, I often get on stage and we talk about applications and use cases of IoT. And if you've been in enough IoT conferences, you've heard them all, probably. You've seen, I could probably come up with one that's unique, but you've heard many of these use cases. But the truth of the matter is these are ideas in our heads, but this is happening today at our customers, in factories, and in China specifically. If in that region specifically, the amount of innovation that's happening in that manufacturing environment is quite magnificent. And here's an example in a video to demonstrate that.
Artificial intelligence technology is transformational and has started to be adopted and deployed into the real world in many different industries. Hikvision, the world's leading surveillance company and the leader of IP cameras, has accumulated more than 10 years deep experience in image processing, data storage, video analytics algorithm, cloud computing, big data technology, and now artificial intelligence. This background has enabled Hikvision to start deploying video AI technology into smart manufacturing. One of the driving forces behind smart manufacturing is smart vision. Enabled by Intel's high-performance and stable architecture, Hikvision's machine vision camera combines perfect image processing and high-speed algorithm execution to deliver fast, accurate information acquisition and identification to manufacturing processes. In the sorting process, Hikvision's industrial machine vision camera reads the barcode rapidly and logs the volume and weight information. It intelligently automates the sorting processing with a throughput of 20,000 orders of parcel per hour, therefore reducing the labor cost by 80%. In addition to smart vision, the Edge Intelligence System is the brain that keeps everything moving with fluidity, precision, and control. The Vision Master Platform runs the deep learning-based algorithm from multiple sources of the video inputs. And through coordination with various production management systems, enables a more autonomous manufacturing process. This includes product line monitoring, sorting, and warehousing. For example, real-time determines the task assignment for the carrying robot fleet and sends the optimized navigation route for robots to effectively move products to its corresponding location. The result is a seamless, efficient, and integrated system that enables robots to navigate products without interfering with each other.
So yes, the robots are coming, and they're there, and specifically in these factories. This is truly happening in their factories. I was able to go to a few of those and been in some other factories within China that you could see how the lines are automating. You'll see a non-automated line, a couple of non-automated lines, and 3 right behind it. So I always wonder what those people working on those lines are thinking, right? Like they're looking back and seeing the machines coming, and they probably know that their days are maybe counted as a result of that. So as we talk about, I'm going to try to bring some of these concepts together, because really where I want to spend some time is, as we talk about us moving through the phases, connected, smart, and autonomous. And as we start to move into this world of autonomy and have capabilities like artificial intelligence and machine learning, and we have inventions and innovations happening there and a great deal of acquisition and investment, so we know that's going to go up. As that starts to happen, what happens to data? What happens to compute? as a result of this transition that we know is inevitable. We know it's happening. It's already in certain parts of the world. Well, of course, data is going to increase, right? All boats will rise, all data improves. So by the end of the year, we see 50% more, actually 10x more in data, 15x just in IoT applications. So 10x overall in data, some of that being content, and then 15x more data just in IoT applications. There's 50% of all of those IoT deployments will be network constrained, because now you just have a ton of stuff happening, right? Think about the robots, think about the cameras. What's happening with these guys? They're sending data somewhere, right? If they don't have these apps, something needs to happen to limit that amount of data that's happening. Real-time data is going to grow by 40x over the next 8 years. So that's what's growing. It's real-time information. Think about your autonomous car. That's the perfect example of real-time information. But that's one example, and it's probably the coolest one of them all. This stuff is happening in factories. It's happening in your homes. It's happening in cities, in smart cities. I haven't used that example. I'm sure you've heard that example as well, of being able to gather real-time data in smart cities. And so by 2019, which is next year, it's kind of coming up on us really fast, 45% of that data has to be stored and acted upon on the edge. And this is where we now combine that with the innovation of AI and machine learning, and we start to make real decisions. We now have real-time data, because now you know that's growing by 40x, right? And so as this happens, what we've seen traditionally in our world of here's the edge, the network, and the cloud. And for economies of scale, the cloud will always be the best solution to store data. That's the most efficient and allows for the increased amount of economy of scale and allows for data to be collected in one place. But after all the dynamics I just mentioned, that transition, there has to be a transition. And that transition is going to be, we now have the ability to have data that compute. Let's talk about compute for a minute, and I'll talk about data. Compute distributed throughout the entire network. So you have compute at the edge. You may have compute at the network. I know my friends Verizon were here. We may have compute at the network, and we're going to have compute in the cloud. And you'll see compute, AI, and machine learning throughout every phase of the network. So if I mentioned already, the cloud will always be the simplest solution because of economies of scale. Why would compute go distributed? But I've already mentioned one reason why it happens. The networks are constrained, right? The network, 40% of your applications, or about 50% of your applications are constrained by the network. It just can't take that much data. And yes, 5G is coming, and yes, it's a magnificent solution. The networks are going to be constrained, right? Despite that. Yes, 5G will help with our latency solutions, but real-time data is still a different dynamic. Depends on what you mean by real-time. Real-time's a scale. So one is having the networks constrained. Number two, I already mentioned, started to mention, which is latency. When you're making real-time decisions, whether it be a robot that you're trying to control, whether it be a vehicle that you're trying to control, something that is safety-critical application. Again, 40% of the data that's increasing is 40x of the data that's increasing is real-time. And so as a result, the compute's moving distributed and more of it being at the edge. And then the one that I hear that I did not expect to hear as much as I'm hearing, and maybe I should have, quite often I hear it a lot overseas, as much as I hear it here, but it's privacy. I don't want to let my data go. I don't know what's out there. I want it on my factory floor. I want all my data here. I want it local to me. And so that's causing this distribution of networks. Now, let me be very clear that when we do this, all boats do rise. Data is across the board. And data will be in the cloud, data will be in the network, and then there'll data at the edge. But this edge data allows for a new technique of distributed compute. And that's where we start talking about security. Because now you have not just the security that we talk about, which is your IoT application that's sending data to the cloud, and then security that you need to talk about at that thing, and then the cloud. We now have distributed compute happening, distributed data data is everywhere, and AI and machine learning allowing for decisions to be made throughout your entire solution. And so as a result of that, your security solution also has to accommodate for that. And security is actually the #1 barrier that we see to scale in IoT. Even before you start talking about autonomy and AI and machine learning and distributed compute, today just simple applications like plugging in a light bulb is complicated because your IT/OT systems. And so now complicate that system even more with this technology that you're having to distribute compute, distribute data, and distribute analytics and throughout the network. It now becomes the #1 barrier to scale and the #1 barrier for solutions to get out. So people are moving more towards hardware-based mechanisms for security. Intel is obviously very much investing in hardware-based security because that is a much easier way, especially when compute and analytics start to happen on the edge. And we're working with the industry towards a platform security architecture called PSA. So we have some security standards that enables our customers to scale. One of the easiest ways is to start to create some standards around this industry, around security as you start to distribute compute. What are your architecture going to look like at the edge? And we just released a solution called Secure Device Onboard. So it allows for the onboarding of security devices onto your network and allows for that to be managed throughout. But I also want to add what we started talking about in the panel, which is blockchain, and how blockchain may actually integrate well into this new world order where distribution of decisions, distribution of compute, and distribution of artificial intelligence. And so blockchain, as most of you know, has traditionally been known for what it can do in the financial institution with Bitcoin. It's usually in public networks. But we believe, though, that with enterprise and private networks for provisioning, that blockchain can be a great solution now allowing for some of these distributed computes. And there's a couple of applications that we've looked at Intel to see, is this a good solution for some of the problems we're having in IoT? #1 is just, we'll talk about just having data that we don't want to tamper with, right? Insurance data, health data, automotive data. You could use technologies like blockchain to secure data that you don't want tampered with that's actually moving hands. So it's insurance data, it's records, it's health stuff. But when we start to have multiple parties having concurrent access to the data, which is what's happening when you start to distribute this compute, and where you have supply chain issues, where everybody's looking at this data, that's another very good application for what we believe blockchain can solve for. And so this is where we've been looking at blockchain a little bit closer to see, is there a transition into IoT? I think you already started looking at it. You talked about it in your panel, and we have very similar views on that. We do believe that there's an application for this. We believe that there's a hardware-software solution to it as well, and something that Intel can have a position in. But it's actually not, I want to reduce some of the allure with blockchain. It is a really good technology, but it really is a distributed records management. It happened to be used in Bitcoin, and it's not a financial solution. It really just allows for the management of data in a distributed fashion, right? Which is, again, what I've been talking about along with distributed compute. So we look at it as a tool, and this is how Intel will look at it: immutable, decentralized, distributed, permanent, and auditable. And so if you look at those attributes and then the applications that I talked about, you can see that there is definitely a connection and one that we can leverage. Another barrier to solutions in IoT, I talk about security, I talk about distributed compute, and then how blockchain could possibly be a solution, and one that we're investigating. Another one that most all of you probably know very well is just this value chain, right? I hear often IoT is like a snowflake. Everything is just slightly different, right? And honestly, I have never spoken to a customer. I hear it more now. I haven't heard it yet, but I see people moving towards that says, I am an IoT customer. What they will say is, I do factories, I do pharmaceuticals, I do health. And so each one of these industries, they're true solutions, that each one of them are uniquely different, and each one of them have very key attributes that are necessary for them to be successful, and they have scale challenges that are unique to each one of these industries, right? Very often, one of the things I look at is factory automation, and I get this, we want to automate our factories. Like, yeah, what does that mean, right? When you want to automate your factory. So until you actually go into the factory line and you understand what are the challenges in that factory line, are they having problems with inventory? Are they trying to customize their factory line? Again, each one of these solutions are very, very different. And so how do you start to create some synergy? Because if each one is done uniquely different, we cannot scale, and the investment's way too high. And so we have to start looking for how we create standards, and then the industry comes together. Just a couple of months ago, I was in Washington, and one of the conversations I was having there is, how can we take advantage of the industry and the momentum we already have in the industry? And I actually went to Washington with Samsung, which wouldn't actually usually have been normal for Samsung and Intel to be standing together, but we stood together and said, the industry is coming together, and we're willing to create standards and start to enable scale, but don't override us. Allow us to do this, because these consortiums are coming together. We are creating standards in the industry, and if you start to create momentum around the standards we're already creating, then we can see that this is going to enable scale for all of us in the United States specifically, where these guys in Washington truly care about. And so, talking about standards, some of these standards that we specifically are focused in to help for scale. Let's talk about Edge Computing Consortium. This is specifically came out of China. It's 116 members that are part of that, working towards allowing for edge computing. Edge computing is not much of a different word than distributed computing that I used earlier, which is allowing for distribution of compute and analytics. Another word for that would be edge computing. Another fancy word, open fog. So not very different than what I had mentioned earlier. Why would you use an open fog solution? Because you've got latency concerns, you've got privacy concerns. So that's 57 members. Intel is actually leading that consortium. The Open Group, which creates open, secure, interoperable process control architecture. And then the OPC Foundation, which has 515 members. So again, working pretty aggressively with the rest of the industry, and the unique balance, the standards organization, the organization that runs standards reports to me at Intel, and it's the conversation we're having on a regular basis, which is, where do we create standards, and where do we have differentiation? And that's one, as the industry comes together and we see it evolving. I think there's algorithms in AI, there's techniques in AI, there's techniques in blockchain security, there's techniques in machine learning that allow us to have differentiation. But a great deal of this, it's no different than our old USB stick. How do we connect? How do we make sure that we can have interoperable solutions? So as we continue to evolve in the industry, the potential of the industry, you've seen these numbers. It's by 2027, we're talking $4 trillion a year that this market, the IoT market, all of this automation as we see across the board. And one thing I will reflect on personally, I have been in the industry for quite some time. It's kind of hard for me to say that. But this is the first time in my career that I've seen multiple industries transforming all at once. And I'm in this beautiful position to see it all happening, and the similarities in which they're transforming. And in the position that I'm in, I see retail, because that's one of the verticals we focus on, industrial, automotive, and then we have agricultural and health. And we see all of these industries, but some of the topics that I spoke about go across the board. The thought of latency and distributed compute, and compute moving to the edge, the need for artificial intelligence, the need for increased connectivity, 5G and what it enables us in getting more of these restricted networks opened up, right? One of the topics that we talked about barely touched on 5G, and my presentation doesn't touch on it, but one of the comments, I don't remember who, you may have made it, I'm not sure, you were talking about how it's just, 5G allows for, the idea of spectrums goes away, that it is really truly interoperable, that it allows for connectivity to transition between networks. And so this is happening for us, and the momentum is definitely there in the industry. Thank you for having me.